Okay, let's dive right into this. Welcome to The Explainer. If you've been paying any attention to the global tech landscape lately, you know there's a quiet but absolutely massive war brewing over the physical architecture of the future. Today we're unpacking the Intel and Elon Musk alliance. This is a monumental move aimed at nothing less than completely dismantling TSMC's 30 years semiconductor monopoly. And they're planning to pull it off with a project called Terafab.
To understand why Terafab is such a seismic shift, we have to look at the terrifying fragility of the world's most important technology supply chain. I mean, think about it. What happens when a $119 billion industry relies on a single, fragile 10,000-mile chain? It really puts the whole AI boom into perspective. The entire foundation of modern computing relies on a framework that is remarkably vulnerable, and it's acting as a massive bottleneck for AI development across the globe.
Right now, for an advanced AI chip to even be born, it goes on this agonizing four-continent journey. Step 1, it starts with design in the United States. Step 2, it crosses the Pacific for printing in Taiwan. Step 3, those fragile wafers are flown to Asia for packaging. And finally, Step 4, it flies all the way back to the US for testing. And here's the real kicker. At every single one of these physical bottlenecks, companies get hit with a 2 to 4 week delay.
And this brilliantly illustrates the financial weight of this legacy process. $20,000. That is the exorbitant cost just to print the lithographic circuits onto a single leading-edge silicon wafer in Taiwan. And that is before you even factor in the packaging and testing costs.
Plus, you're flying this incredibly fragile, insanely expensive piece of silicon back and forth across 10,000 miles of the Pacific Ocean. You're piling up massive customs hurdles, really complex logistical risks, and exorbitant cargo insurance costs just to move what is essentially high-tech sand. But, even with all that friction, the cost and the distance actually aren't the biggest problems.
The real fatal flaw of this legacy system? 120 days. In the AI era, microcircuit flaws are incredibly common, like a short circuit happening the second a chip hits 150 degrees Celsius in a data center. Under the old system, fixing that flaw means redesigning blueprints in the US, sending the files to Taiwan, waiting in line for a new photomask set, fabricating, and then shipping it back. That entire correction cycle eats up 90 to 120 days. It's brutal.
Which brings us to Section 1, the Terafab paradigm, absolute vertical integration.
Born in Austin, Texas, Terafab isn't trying to beat TSMC at their own game of scaling perfectly. Instead, they're completely flipping the board by shifting to absolute vertical integration. By consolidating the entire chain under one roof in Austin, Musk is changing the very physics of production. You've got design, mask fabrication, wafer casting, extreme ultraviolet lithography, advanced packaging, and final testing, all on a single unified campus. So when an engineer finds a flaw, they don't schedule a cross-time zone video call or wait for a cargo ship. They just walk a few doors down the hall to collaborate directly with the material process engineers.
Now, what's really interesting about this slide is the sheer scale of the evolutionary jump. Because of that 120-day delay we just talked about, TSMC allows its customers to fail and correct a design maybe 3 to 4 times a year. But look at Terafab's integrated model. It allows engineers to execute up to 24 iterations in a single year. They've effectively turned physical, heavy manufacturing into an ultra-agile system.
Let's move into Section 2, speed as a weapon, shrinking time.
The fundamental math behind this disruption is that the winner in today's semiconductor race isn't the guy with the biggest factory. It's the one with the fastest rate of learning. Let's look at that contrast again. 120 days. That agonizing legacy correction cycle literally causes tech giants to bleed billions of dollars in delayed revenue, just because they have to wait a quarter of a year to see if a circuit fix actually worked.
Now compare that to Terafab, 10 to 15 days. Seriously, by utilizing a $2 billion internal mask writing system, they compress that excruciating wait time by 10 to 20 times. They can independently crank out a new photo mask set in 24 to 48 hours instead of 45 days. The new wafer just rolls off the line days later.
Think of it this way. They're basically taking physical silicon hardware and treating it like software. It's transforming chip manufacturing from a heavy, logistics-driven industry into a piece of software that can deploy a patch every 2 weeks. They are completely redefining how humanity creates the physical brain for artificial intelligence.
Let's move to Section 3 and see how this builds in physical space, under the hood, the 2-nanometer reality.
It's super easy to make bold claims, but we need to ground this in physical reality so you know this isn't just vaporware.
Terafab is targeting the ultra-advanced 2-nanometer process node. To pull that off, they've established a seriously heavy-duty arsenal. 12 next-gen extreme ultraviolet lithography systems from ASML, which are some of the most complex machines ever built, along with that $2 billion e-beam mask writing system we mentioned, and an initial capacity of 100,000 wafers per month. This ensures abundant supply without ever having to rely on third-party foundry schedules.
And this massive infrastructure is custom-built to serve two extremely distinct physical realities within Musk's ecosystem. On one side, you have the AI-6 chip. It packs 100 billion transistors while keeping power consumption under 150 watts, which is perfect for terrestrial AI like Tesla's full self-driving, Optimus humanoid robots, and XAI servers. Then, on the totally opposite extreme, you have the D3 chip. This is custom-engineered for SpaceX and Starlink to survive massive temperature fluctuations, deep space radiation, and constant cosmic particle bombardment without hardware failure.
To make all this work, they rely on a crucial piece of Intel technology called EMIB, or Embedded Multi-Die Interconnect Bridge. Rather than using traditional wire bonding that creates massive bandwidth bottlenecks, EMIB embeds ultra-thin silicon bridges directly beneath the substrate. This breakthrough allows high-bandwidth memory and processors to communicate over microscopic distances, pushing internal data transfer to a record-breaking 1 terabyte per second, and that is absolutely essential for processing the massive AI models of tomorrow without choking on data bottlenecks.
Let's look at the big picture in Section 4, Rewriting Global Security, Beyond the Silicon.
Zooming out from the technical specs, the macroeconomic and geopolitical impact of this new alliance is genuinely staggering. For decades, TSMC has reigned supreme by operating on a specific metric: manufacturing scale and yield rate. Basically, whoever makes the most chips with the lowest defect rate wins. But the Intel-Musk alliance imposes an entirely new metric: the speed of mechanical evolution. TSMC's flawless scaling is incredible, for sure, but it is largely helpless against a system that's designed to constantly negate its own legacy versions through rapid-fire internal iterations.
So, the crucial point is how they make this financially viable. Historically, U.S. chip manufacturing was considered absolute financial suicide because of the costs. But by utilizing the cutting-edge Intel 14A process node, pulling direct subsidies from the CHIPS and Science Act, and completely suffocating the hidden costs of global warehousing, logistics, and insurance, they totally reversed the math. Every dollar saved on those logistical nightmares turns into a surplus that's directly reinvested right back into R&D.
But perhaps the most vital takeaway is what this means for global security. Right now, more than 90% of the world's advanced artificial brains are manufactured in a single, strategically sensitive territory in Taiwan. It's a sword of Damocles hanging over every tech titan and the entire global digital economy. Terafab essentially offers an insurance policy, absolute security, engineered right in the domestic heartland of the United States.
And that leaves us with a fascinating, highly disruptive question. Once Terafab successfully proves its viability and speed, will the capital flight and order migration away from East Asia become an irreversible process? It would be a fundamental rewriting of the world's most critical supply chain. Keep pondering that shift. Thanks for joining me on this explainer, and I'll catch you on the next deep dive.